Miscellaneous exercise 1. Question number 1. Write down the following sets in set builder form. Solution. Number 1. Set of 10, 20, 30, 40, 50. Let A is equal to set of 10, 20, 30, 40, 50. A is a set of natural numbers which are 10 times n, where n belongs to n and n is less than or equal to 5. Therefore, A is equal to set of all x such that x is equal to 10n, where n belongs to n is less than or equal to 5. Number 2. Set of A, E, I, O, U. Let B is equal to set of A, E, I, O, U. B is the set of all vowels of English alphabets. Therefore, B is equal to set of all x such that x is a vowel of English alphabets. Number 3. Set of Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Now let's see is equal to set of Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. C is the set of all days of the week. Therefore, C is set of all x such that x represents the day of the week. Question number 2. If U is equal to set of all x such that x belongs to n, x is greater than or equal to 1 but less than or equal to 12, A is equal to set of 1, 4, 7, 10, and B is equal to set of 2, 4, 6, 7, 11. C is equal to set of 3, 5, 8, 9, 12. Write down the following sets. Number 1. A union B. Solution. Now U is equal to set of all x such that x belongs to n, x is greater than or equal to 1 but less than or equal to 12. Therefore, U is equal to set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Number 1. A union B. A union B would be set of 1, 4, 7, 10, union 2, 4, 6, 7, 11. So it will be set of 1, 2, 4, 6, 7, 10, 11. Number 2. B intersection C. Now B intersection C would be set of 2, 4, 6, 7, 11, intersection 3, 5, 8, 9, 12, that is equal to 5. Number 3. A minus B. Now A minus B is set of 1, 4, 7, 10 minus set of 2, 4, 6, 7, 11. That will be set of 1, 10. Number 4. B intersection C complement. Now C complement is set of 1, 2, 4, 6, 7, 10, 11. Therefore, B intersection C complements would be set of 2, 4, 6, 7, 11 intersects 1, 2, 4, 6, 7, 10, 11. So it is set of 2, 4, 6, 7, 11. Number 5. A union B union C. Well, A union B union C would be set of 1, 4, 7, 10, union set of 2, 4, 6, 7, 11, union set of 3, 5, 8, 9, 12. So it is set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Number 6. A intersection B union C. Now first we'll find B union C, that is set of 2, 4, 6, 7, 11, union set of 3, 5, 8, 9, 12. So it is set of 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. Now A intersection B union C would be set of 1, 4, 7, 10, intersection set of 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. So it is set of 4, 7. Question number 3. In a survey of 425 students in a school, it was found that 115 drink apple juice, 160 drink orange juice, and 80 drink both apple as well as orange juice. How many drink neither apple juice nor orange juice? Solution. Let X be set of all students. A. Set of students who drink apple juice. B. Set of students who drink orange juice. We are given the following. Now number of X is 425. Number of A would be 115. Number of B 160. And number of A intersection B 80. The Venn diagram is shown below. Now the number of students who drink neither apple juice nor orange juice would be number of complement of A union B. So it is number of X minus number of A union B, that is 425 minus 35 plus 80 plus 80. That is 425 minus 195, which is 230. Question number 4. In a school, there are 20 teachers who teach mathematics or physics. Of these, 12 teach mathematics and 4 teach both mathematics and physics. How many teach physics? Solution. Now let M be set of teachers who teach mathematics, P be set of teachers who teach physics. We are given that number of M union P is equal to 20, number of M is 12, number of M intersection P is 4. We know that number of M union P is equal to number of M plus number of P minus number of M intersection P. Therefore, number of P is equal to number of M union P plus number of M intersection P minus N number of M. That is 20 plus 4 minus 12, which is 12. Hence, the number of teachers who teach physics are 12. Question number 5. Number 1. If A is equal to set of 1, 2, 3, B is equal to set of 2, 4, write down the following. A cross A cross B, B cross A, B cross B, A cross B intersection B cross A. Solution. Now A is set of 1, 2, 3. B is set of 2, 4. Now A cross A would be set of 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. A cross B would be set of 1, 2, 1, 4, 2, 2, 2, 4, 3, 2, 3, 4. B cross A would be set of 2, 1, 2, 2, 2, 3, 4, 1, 4, 2, 4, 3. B cross B would be set of 2, 2, 2, 4, 4, 2, 4, 4. Now A cross B intersection B cross A would be set of 1, 2, 1, 4, 2, 2, 2, 4, 3, 2, 3, 4, intersection 2, 1, 2, 2, 2, 3, 4, 1, 4, 2, 4, 3. Now the answer would be 2, 2. Number 2. If A is equal to set of minus 1, 1, find A cross A. Solution. Now we are given that A is minus 1, 1. Therefore A cross A would be minus 1, 1, cross minus 1, 1, cross minus 1, 1. So it is minus 1, minus 1, minus 1, minus 1, minus 1, 1, minus 1, 1, minus 1, minus 1, 1, 1, 1, 1, 1, 1, 1, minus 1, 1, minus 1, 1, 1, minus 1, minus 1. 6. If A is equal to set of 1, 2, 3 and B is equal to set of 4, 5, 6, which of the following are relations from A to B? Number 1. R1 is equal to set of 1, 4, 1, 5, 1, 6. Solution. A is set of 1, 2, 3. B is set of 4, 5, 6. Therefore, A cross B would be set of 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, 3, 6. Therefore, R1 is equal to set of 1, 4, 1, 5, 1, 6. Since all the elements of R1 are in A cross B, so R1 is subset of A cross B. Therefore, R1 is the relation from A to B. Number 2. R2 is equal to set of 1, 5, 2, 4, 3, 6. Now R2 is set of 1, 5, 2, 4, 3, 6. Since all the elements of R2 are in A cross B, so R2 is also a subset of A cross B. Therefore, R2 is the relation from A to B. Number 3, R3 is equal to set of 1, 4, 1, 5, 3, 6, 2, 6, 3, 4. Now R3 is set of 1, 4, 1, 5, 3, 6, 2, 6, 3, 4. Since all the elements of R3 are in A cross B, again R3 is subset of A cross B. So R3 is a relation from A to B. Number 4. R4 is set of 4, 2, 2, 6, 5, 1, 2, 4. Now R4 is set of 4, 2, 2, 6, 5, 1, 2, 4. Since 4, 2 is not A cross B and even 5, 1 is not A cross B, so R4 is not the subset of A cross B, which means R4 is not the relation from A to B. Question number 7. Determine the domain and range of the following relations. Number 1. R is equal to set of A, B such as A belongs to N, A is less than 5, B is equal to 4. Solution. R is set of A, B such as A belongs to N, where A is less than 5, B is equal to 4. Domain of R is set of all A such as A belongs to N, A is less than 5. That means it is set of 1, 2, 3, 4. Range of R is set of all B such as B belongs to 4. So it is set of 4. Number 2. S is equal to set of A, B such that B is equal to mod of A minus 1, where A belongs to Z, mod of A is less than or equal to 3. Solution. Now we have S is equal to set of A, B such that B is equal to mod of A minus 1, where A belongs to Z, mod of A is less than or equal to 3. Domain of S is equal to set of all A such that A belongs to Z, mod of A is less than or equal to 3. That is set of minus 3, minus 2, minus 1, 0, 1, 2, 3. Range of S is equal to set of all B such that B is equal to mod of A minus 1, where A belongs to Z, mod of A is less than or equal to 3. That is set of mod of minus 3 minus 1, mod of minus 2 minus 1, mod of minus 1 minus 1, mod of 0 minus 1, mod of 1 minus 1, mod of 2 minus 1, mod of 3 minus 1. That is set of 4, 3, 2, 1, 0, 1, 2, which is set of 0, 1, 2, 3, 4. Question number 8. Which of the following relations are functions? If it is a function, determine its domain and range. Number 1. Set of 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 7. Solution. Now let f is equal to set of 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 7. F is a function because every element of the domain of F is related with 1 and only one element of the range of F. Domain of F is equal to set of 2, 4, 6, 8, 10, 12, 14. Range of F is equal to set of 1, 2, 3, 4, 5, 6, 7. The second component of each ordered pair in F is half of the first component in the same ordered pair. If we denote any element of the domain set by X, then it is related to X upon 2 in the range set. Hence, the formula to exhibit the function f is f of x is equal to x upon 2 for all x belong to domain of f. Number 2. Set of 0, 0, 1, 1, 1, minus 1, 4, 2, 4, minus 2, 9, 3, 9, minus 3, 16, 4, 16, minus 4. Now let f is equal to 0, 0, 1, 1, 1, minus 1, 4, 2, 4, minus 2, 9, 3, 9, minus 3, 16, 4, 16, minus 4. Now, f is not a function because the elements 1, 4, 9 and 16 of the domain of f are related to two distinct elements of the range. Number 3. Set of 2, 1, 3, 1, 5, 2. Solution. Let f is equal to set of 2, 1, 3, 1, 5, 2. F is a function because every element of the domain of f is related with 1 and only one element of the range of f. Domain of f is equal to set of 2, 3, 5. Range of f is equal to set of 1, 2. This function cannot be exhibited by formula. Question number 9. Find whether the following functions are 1, 1 or not. Number 1. Function from R to R defined by f of x is equal to x square plus 5. Solution. Let x1, x2 belongs to R such that f of x1 is equal to f of x2. Therefore, x1 square plus 5 is equal to x2 square plus 5 since f of x is equal to x square plus 5. Now x1 square is equal to x2 square, so x1 is equal to plus minus x2, which means f is not 1, 1 function. Number 2. Function from R minus 3 to R defined by f of x is equal to 5x plus 7 upon x minus 3 for x belongs to R minus 3. Solution. Let x1, x2 belongs to R minus 3 be such that f of x1 is equal to f of x2, which means 5x1 plus 7 upon x1 minus 3 is equal to 5x2 plus 7 upon x2 minus 3. Since f of x is equal to 5x plus 7 upon x minus 3. Therefore, 5x1 plus 7 into x2 minus 3 is equal to 5x2 plus 7 into x1 minus 3, which means 5x1 x2 minus 15x1 plus 7x2 minus 21 is equal to 5x1x2 minus 15x2 plus 7x1 minus 21. So minus 15x1 plus 7x2 is equal to minus 15x2 plus 7x1, which means minus 22x1 is equal to minus 22x2. So x1 is equal to x2. Well, you can say that f is one function. Question number 10. Find whether the following functions are onto or not. Number 1. Function from z to z defined by f of x is equal to 6x minus 7 for all x belongs to z. Solution. Let y belongs to z. We want to get x belongs to z such that y is equal to f of x. That is, y is equal to 6x minus 7. So x is equal to y plus 7 upon 6. But y plus 7 upon 6 does not belong to z for all y belong to z. Therefore, for any y belong to codomain z, there does not exist an element x belong to domain z such that f of x is equal to y. Therefore, f is not onto function. Number 2. Function from R to R defined by f of x is equal to x square plus 3 for all x belong to R. Solution. Let y belong to R. We want to get x belong to R such that y is equal to f of x. That is, y is equal to x square plus 3. Therefore, x is equal to plus minus whole root y minus 3. But plus minus whole root y minus 3 does not belong to R if y is less than 3. Therefore, for any y belong to codomain R, there does not exist x belong to domain R such that f of x is equal to y, which means f is not onto function. Question number 11. Let function from R to R be a function defined by f of x is equal to 5x cubed minus 8 for all x belong to R. Show that f is 1 and onto. Hence, find f inverse. Solution. Let x1, x2 belong to R be such that f of x1 is equal to f of x2. Therefore, 5x1 cubed minus 8 is equal to 5x2 cubed minus 8, since f of x is equal to 5x cubed minus 8. Now, 5x1 cubed is equal to 5x2 cubed, which means x1 cubed is equal to x2 cubed. So, x1 is equal to x2. Therefore, f is 1 function. Let y belong to R. We want to get x belong to R such that y is equal to f of x. That is, y is equal to 5x cubed minus 8. Therefore, x is equal to cube root y plus 8 upon 5 belong to R. Therefore, for any y belong to codomain R, there exists an element x is equal to whole cube root y plus 8 upon 5 belong to domain R such that f of x is equal to y. Therefore, f is onto function. Hence, f is 1 onto function. Let y is equal to f of x is equal to 5x cubed minus 8. So, x is equal to whole cube root y plus 8 upon 5. Inverse of f of y is equal to whole cube root y plus 8 upon 5. Inverse of f of x is equal to x plus 8 upon 5 whole raised to power 1 upon 3. Question number 12. A function f from R to R defined by f of x is equal to 3x upon 5 plus 2, x belong to R. Show that f is 1, 1 and on 2, hence find inverse of f. Solution: let x1, x2 belong to R be such that f of x1 is equal to f of x2. Therefore, 3x1 upon 5 plus 2 is equal to 3x2 upon 5 plus 2, since f of x is equal to 3x upon 5 plus 2. Therefore, 3x1 upon 5 is equal to 3x2 upon 5, which means x1 is equal to x2. Therefore, f is 1, 1 function. Let y belong to R. We want to get x belong to R such that y is equal to f of x. That is, y is equal to 3x upon 5 plus 2. Therefore, 3x upon 5 is equal to y minus 2. Therefore, x is equal to 5 into y minus 2 upon 3 belong to R. Therefore, for any y belong to codomain R, there exists an element x is equal to 5 into y minus 2 upon 3 belong to domain R, such that f of x is equal to y. Therefore, f is onto function. Hence, f is 1, 1 onto function. Let y is equal to f of x is equal to 3x upon 5 plus 2. Therefore, x is equal to 5 into y minus 2 upon 3, which means inverse of f of y is equal to 5 into y minus 2 upon 3. So inverse of f of x is equal to 5 into x minus 2 upon 3. Question number 13. A function f is defined as follows. F of x is equal to 4x plus 5 for x is greater than or equal to minus 4 but less than 0. Find the value of f of minus 1, f of minus 2, f of 0 if exist. Solution: f of x is equal to 4x plus 5 for x is greater than or equal to minus 4 but less than 0. Therefore, f of minus 1 is equal to 4 into minus 1 plus 5, that is minus 4 plus 5, which is 1. F of minus 2 is equal to 4 into minus 2 plus 5, that is minus 8 plus 5, which is minus 3. F of 0 does not exist because 0 does not belong to domain of f. Question number 14. A function f is defined as follows. F of x is equal to 5 minus x for x is greater than or equal to 0 but less than or equal to 4. Find the value of x such that f of x is equal to 3 and f of x is equal to 5. Solution: f of x is equal to 5 minus x for x is greater than or equal to 0 but less than or equal to 4. Number 1. If f of x is equal to 3, then 5 minus x is equal to 3, so x is equal to 2. Number 2. If f of x is equal to 5, then 5 minus x is equal to 5, so x is 0. Question number 15. If f of x is equal to 3x raised to power 4 minus 5x square plus 7, find f of x minus 1. Solution: f of x is equal to 3x raised to power 4 minus 5x square plus 7. Therefore, f of x minus 1 is equal to 3 into x minus 1 whole raised to power 4 minus 5 into x minus 1 whole raised to power 2 plus 7. So it is equal to 3 into x raised to power 4 minus 4x cube plus 6x square minus 4x plus 1 minus 5 into x square minus 2x plus 1 plus 7. So it is equal to 3x raised to power 4 minus 12x cube plus 18x square minus 12x plus 3 minus 5x square plus 10x minus 5 plus 7. Therefore, f of x minus 1 is equal to 3x raised to power 4 minus 12x cube plus 13x square minus 2x plus 5. Question number 16. If f of x is equal to 3x plus a and f of 1 is equal to 7, find a and f of 4. Solution: f of x is 3x plus a. F of 1 would be 3 into 1 plus a, that is 3 plus a. F of 1 is equal to 7 gives 3 plus a is equal to 7. So the value of a is 4. Now f of x is equal to 3x plus 4. So f of 4 would be 3 into 4 plus 4, that is 16, which means the value of a is 4 and f of 4 is 16. Question number 17. If f of x is equal to ax square plus bx plus 2 and f of 1 is equal to 3, f of 4 is equal to 42, find a and b. Solution: f of x is equal to ax square plus bx plus 2. Therefore, f of 1 would be a into 1 square plus b into 1 plus 2, that is a plus b plus 2. F of 1 is equal to 3, which means a plus b plus 2 is equal to 3. So we can find a plus b as 1. Also, f of 4 is equal to a into 4 square plus b into 4 plus 2, that is 16a plus 4b plus 2. So f of 4 is given as 42, which means 16a plus 4b plus 2 is equal to 42. So 16a plus 4b is 40. So 4a plus b is equal to 10. Let us put this equation as 2. If you subtract equation 1 from 2, you get 3a as 9. So value of a is 3. From 1, 3 plus b is 1. So value of b is minus 2. Hence, a is 3 and b is minus 2. Question number 18. Find composite of f and g and express it by formula. Number 1. F is equal to set of 1, 3, 2, 4, 3, 5, 4, 6. G is equal to set of 3, 6, 4, 8, 5, 10, 6, 12. Solution. Number 1. Let A is equal to set of 1, 2, 3, 4. B is equal to set of 3, 4, 5, 6. And C is equal to set of 6, 8, 10, 12. Now, F is equal to set of 1, 3, 2, 4, 3, 5, 4, 6. Here, f of 1 is equal to 3, which is equal to 1 plus 2. F of 2 is equal to 4, that is 2 plus 2. F of 3 is equal to 5, that is 3 plus 2. F of 4 is equal to 6, that is 4 plus 2. Therefore, in general, f of x is equal to x plus 2, x belongs to A. Also, g is equal to set of 3, 6, 4, 8, 5, 10, 6, 12. Here, g of 3 is 6, that is 2 into 3. G of 4 is 8, that is 2 into 4. G of 5 is 10, that is 2 into 5. And g of 6 is 12, that is 2 into 6. Therefore, in general, g of x is 2x, x belongs to B. G of f of x is g of f of x, that is 2 into f of x, which means it is 2 into x plus 2, that is 2x plus 4. So g of f of x would be 2x plus 4, x belongs to A. So g of f is equal to set of 1, 6, 2, 8, 3, 10, 4, 12. Number 2, f is equal to set of 1, 1, 2, 4, 3, 4, 4, 3. G is equal to set of 1, 1, 3, 27, 4, 64. Now let A is equal to set of 1, 2, 3, 4. B is equal to set of 1, 3, 4. And C is equal to set of 1, 27, 64. Now f is equal to set of 1, 1, 2, 4, 3, 4, 4, 3. Here f of 1 is equal to 1, f of 2 is equal to 4, f of 3 is equal to 4, and f of 4 is equal to 3. Also, g is equal to set of 1, 1, 3, 27, 4, 64. Here g of 1 is equal to 1, g of 3 is equal to 27, g of 4 is equal to 64. Therefore, g of f of 1 would be g of f of 1, that is g of 1, which is 1. G of f of 2 would be g of f of 2, that is g of 4, which is 64. G of f of 3 would be g of f of 3, that is g of 4, which is 64. G of f of 4 would be g of f of 4, that is g of 3, which is 27. Therefore, g of f is equal to 1, 1, 2, 64, 3, 64, 4, 27. Question number 19. Find f of g and g of f. Number 1. F of x is equal to x square plus 5. G of x is equal to x minus 8. Solution. F of x is x square plus 5 and g of x is x minus 8. Therefore, f of g of x would be f of g of x, that is f of x minus 8, which is x minus 8 whole square plus 5, which is x square minus 16x plus 64 plus 5. So f of g of x would be x square minus 16x plus 69. Also, g of f of x would be g of f of x, that is g of x square plus 5, that is x square plus 5 minus 8. So g of f of x would be x square minus 3. Number 2, f of x is equal to 3x minus 2. G of x is equal to x square. Now f of x is equal to 3x minus 2. G of x is equal to x square. Therefore, f of g of x would be f of g of x, that is f of x squared. Therefore, f of g of x would be 3x squared minus 2. Also, g of f of x would be g of f of x, that is g of 3x minus 2, which is 3x minus 2 whole square. Therefore, g of f of x is equal to 9x squared minus 12x plus 4. Number 3. F of x is equal to 256 x raised to power 4. G of x is equal to root x. Now, f of x is 256 x raised to power 4. G of x is root x. Well, f of g of x would be f of g of x, that is f of root x, which is equal to 256 into root x whole raised to power 4. Therefore, f of g of x would be 256x squared. Also, g of f of x would be g of f of x, that is g of 256x raised to power 4, which is whole root 256x raised to power 4. So, g of f of x would be 16x squared. Question number 20. If f of x is equal to 2x plus 1 upon 5x minus 2, x is not equal to 2 upon 5, show that f of x is equal to x. Solution. F of x is equal to 2x plus 1 upon 5x minus 2. Therefore, f of x would be f of x, that is f of 2x plus 1 upon 5x minus 2, which means it is 2 into 2x plus 1 upon 5x minus 2 plus 1 upon 5 into 2x plus 1 upon 5x minus 2, which is equal to 2 into 2x plus 1 plus 5x minus 2 upon 5 into 2x plus 1 minus 2 into 5x minus 2, which is 4x plus 2 plus 5x minus 2 upon 10x plus 5 minus 10x plus 4, that is 9x upon 9, which is x. Question number 21. If f of x is equal to x plus 3 upon 4x minus 5, g of x is equal to 3 plus 5x upon 4x minus 1, show that f of g of x is equal to x. Solution. F of x is x plus 3 upon 4x minus 5. G of x is equal to 3 plus 5x upon 4x minus 1. Therefore, f of g of x is f of g of x. That is f of 3 plus 5x upon 4x minus 1, which is equal to 3 plus 5x upon 4x minus 1 plus 3 upon 4 into 3 plus 5x upon 4x minus 1 minus 5, which is equal to 3 plus 5x plus 3 into 4x minus 1 upon 4 into 3 plus 5x minus 5 into 4x minus 1, that is 3 plus 5x plus 12x minus 3 upon 12 plus 20x minus 20x plus 5, that is 17x upon 17, which is x. Question number 22. Let f from r minus 2 to r be defined by f of x is equal to x squared minus 4 upon x minus 2, and g from r to r be defined by g of x is equal to x plus 2. Find whether f is equal to g or not. Solution. Since 2 does not belong to domain of f, so f of 2 does not exist. whereas g of 2 exists because 2 belongs to domain of g and g of 2 is equal to 2 plus 2 that is equal to 4. So f of x is not equal to g of x for all x. Hence, f is not equal to g.
Miscellaneous exercise 1. Question number 23. Let f of r corresponds to r of f of x that equals to x plus 5 for all x belongs to R. Find its domain and range. Also, draw its graph. Answer. F is a set of x, f of x, where f of x is equal to x plus 5 and x belongs to R. Therefore, domain of f is equal to R and range of f is equal to R. Now, to plot the graph, let us make a table mentioning the points x and f of x. If x is equal to 1, f of x is equal to 1 plus 5, that is 6. If x is equal to 2, f of x is equal to 2 plus 5, that is 7. If x is equal to 3, f of x is equal to 3 plus 5, that is 8. If x is equal to 0, f of x is equal to 0 plus 5, that is 5. Now let us draw the x-axis and y-axis. On x-axis, let us plot the points for x, and on y-axis, let us plot the points for f of x. Scale on both the axes is 1 centimeter is equal to 1 unit. Now let us plot the point 1, 6. It is here. Point 2, 7 is here. Point 3, 8 is here. And point 0, 5 is here. Now let us draw a straight line passing through all these points in this way.
Question number 24. Let f from R to R be defined by f of x is equal to x cubed for all x belong to R. Find its domain and range. Also draw its graph. Solution. F of x is equal to x cubed. Since x cubed can be uniquely calculated for every x belong to R, domain is equal to for all values of x such as x belong to R is equal to R, and range is for all values of y such that y is equal to x cubed, x belong to R is equal to R. To draw the graph of y is equal to f of x is equal to x cubed, let us find the values of y for certain value of x. If x is minus 2, then f of x, which is x cubed, would be minus 8. If x is minus 1, then f of x would be minus 1. If x is 0, then f of x would be 0 too. If x is 1, then f of x is 1. If x is 2, then f of x, which is x cubed, is 8. Here is the graph.